going to look at something now called the insertion sort, and that is the sort that people tend to use more naturally than the bubble sort. So what people would do, if they were dealt a set of cards like this, what they would do is start at this end and say, right, are those in the right order? No, they're not. We'll swap them round. Then we'll take the next one, the number 10. Where does that actually go? Well, that's actually in the right place. Then we'll take the number 8. Where does that go in our list over here? Well, we need to move and get them in position, so we get our number 8 in position. Then we take our number 2. Well, our number 2 needs to go right at the beginning, but we'll actually test where does it go, and it goes to the beginning. Then our number 5, where does that go? Smaller than that, smaller than that, smaller than that, and it fits in and goes there. So our insertion sort is basically how people handle cards if they dealt them. Let's go back and mix them up again. So it doesn't really matter what order we put them in, but we'll mix them up and we'll look at that again and take it through a stage at a time. So what happens if somebody gets the cards like this? They will take the first 2 at one end of the pack and they will say, right, okay, the 4 is smaller, the 10 is larger. Then they get the number 9 and they will start from typically this end and say, right, it's smaller than the 10, so it goes into that position there. Then they take the 2 and it's smaller than that, smaller than that, smaller than that, so it actually goes there. And what we've ended up with is, if you like, 2 sets. We've got an unsorted set and we've got a sorted set. And we take each one from the unsorted and find the right position in the sorted set. So we take our 5 comes in, it's lower than the 10, it's lower than the 9, it's higher than the 4, so it will slot in there. And our last card is the 8, smaller than a 10, smaller than a 9, higher than a 5, so that's where it goes. Okay, so let's have a look at the algorithm that we need for the insertion sort. So first of all, we need to set numbers, and you can see I've left the code from before, or at least I have the same numbers as before. So it's 4, 10, 8, 5, 9, 2. So what do we need to do with the insertion sort? Well, with the insertion sort we need to go through each time, and we're going to take our list, and each time we're going to take one item from our list which will become our unsorted list and create our sorted list. So we need to do that for each number. So we need to find out how many there are in the list, so we can have our count again, and we can say length numbers. So now we know how long the list is, and we need to go round the whole list. So we've got for I from 1 to count, do, and then we're going to need to end that for loop. So we know how many times we're going to go round the loop. Let's get this set up, and what we need to do is take our value, which is our next number, or in this case our first number. So value is going to be equal to numbers I, so the first time it will be 1, and we'll set position, we'll call something position, because we need to change position. we need to change that, so that's going to be set to I as well, and we're going to check if our previous item, so we started from 1, remember we've got number 0 which we haven't touched, so number 0 will go across, so we'd say numbers, sorry, let's have a, we'll have a while loop to go around, while numbers, and this is our position before, so position -1 is greater than value, then what we will do is we'll actually swap them over. So we'll say numbers position equals numbers position -1. So in our first instance, if number 0, which is position -1, is greater than our value, then our numbers position needs to have that value, so we've created a gap for it to go into. We also need to then do the same for the next one, so we'd say position equals position -1. Of course, the first time round we don't really want to do that. Let me just correct my spelling mistake. But we do need to do it for all the other times we go around. So we need to go back to our while loop, and we need to put another condition in here, because we position, when we want to do this while position is greater than 0. Yeah, and position is greater than 0. Then we can end our while. So we've gone through our sorted list, gone backwards through there, found out which ones are higher, we've moved them if they are, and then we've created a gap. And we've created a gap at numbers position, and that's where we can slot in our value that we were checking against. So that should be our algorithm for our insertion sort, and I think that should work for all of the different ones. So let's just try that. Okay, so let me move this over here so that I can see it, see what I'm typing in. So I need to do, well, I'm going to print the numbers out so we can see what's happening. First of all, we wouldn't really need to do this, but I've got a print numbers there. Okay, so what I need to do is set my counter equal to length numbers. That's found the length. Then I can have my for loop. My for is going to be I in range, and I'm going to start at 1 but end at count. Okay, and then I need to set value equal to the number from the list, and I'll set the position equal to my index I as well. Then I need my while loop, and let's see, its position is greater than 0, and numbers position -1 greater than value. Then I'm doing my little move, so numbers position equals that -1 and position minus equals 1. Okay, that's, I need to bring that out that way. Then I need to go back and get this in line, so that numbers position equals value, and what we'll do, just out of interest, I'll print it out so we can see what happens at each iteration. So rather than just print it out right at the end, we'll print it out for each iteration. We'll move that up over there now, and we'll just run that. Okay, I've missed a square bracket out there. Let's try again. Okay, bit of a spelling mistake there. And we'll run that one. Okay, so we can see, if we look over on this side, we can see that our first list, our initial list, then the second one is the same because we've actually only took the first position and put it in the right place. Then we get, we took our number 10, number 10 was already in the correct place. Then we take a number 8, and number 8 gets slotted in. Then we take number 5, and number 5 comes across. Then we take number 9, and that just gets moved to the other side of number 10. And then we take number 2, which had to be moved all the way along. So that appears to be working. So there you go, that's an insertion sort.